Hi everyone, welcome back to Chem Help ASAP. Today we are going to be naming monoatomic ions. As a quick refresher, a monoatomic ion is an ion formed from a single element. It does not refer to how many of those atoms you have, simply that it is an element that has either gained or lost electrons. We will go both from the molecular formula to the name and also from the name to the molecular formula. Let's get started. First, let's go over our rules for naming monoatomic ionic compounds. The first rule is our cation is simply named with its elemental name. When we name the anion, we will name it after the cation and we will change its ending to IDE. Now this is a lot easier to see in practice, so let's get to practicing. So taking a look at my first example here, I have a cation and an anion. Notice the cation is always written first. In this example, my cation is barium. I just name it with its elemental name. My anion is sulfur, but I need to change its ending to IDE. So it will become sulfide. This is barium sulfide. Easy, right? Let's go to the next one. My second example, my cation is potassium. I simply name it with its elemental name. Notice I do not have to specify that there are two potassium ions. I simply name it potassium. My anion in this case is oxygen, but I need to change that ending to IDE. So this is simply potassium oxide. My last example, my cation is magnesium. My anion is nitrogen. Again, I need to change its ending to IDE. It simply becomes nitride. Now we are going to reverse this process. In my second column, I have been given the name and I need to give the molecular formula. This is a little trickier. We will have to do some simple math to determine our molecular formula, but I will show you exactly what we need to do. So for my first example, my name is barium sulfide. So I am simply going to write down the two elements that I'm working with. Barium sulfide, that obviously came from sulfur. Now I use my periodic table and I take a look at barium and I say, okay, when barium becomes an ion, what charge does it have? It, of course, has a charge of 2+. I'm going to write that up here as a reminder. Sulfur, when I find sulfur on the periodic table, I'm going to do the same thing. I'm going to say, what is the charge when sulfur becomes an ion? And its charge is simply 2-. Now my goal here is to form a neutral compound. A neutral compound is a compound where all of our charges add to give us 0. So I'm going to switch to my green. If I take a look at my two charges here, I have barium, which is simply a +2. I can even put my positive there. I'm going to add it to my sulfide, which is a -2. You can see here that this does add to give me 0, so I do not have to alter how many of each atom I have. I simply write my compound a little more cleanly without the charges. That is barium sulfide. Let's move on to my next example. Beryllium phosphide. Again, I'm just going to pull the two elements I'm working with. Beryllium phosphide came from phosphorus. Now I'm going to determine what their charges are. If I look at beryllium on the periodic table, I see that it has a charge of 2 plus. Phosphorus, when it is an ion, has a charge of 3 minus. I'm going to switch to my green to do my math. Here is my beryllium's charge. I'm going to add it to my phosphorus. You can already see that this does not form a neutral compound. Right now, the way I've written it, it is a charged compound. In order to fix this problem and get a neutral compound, I need to multiply my beryllium times 3 and my phosphorus times 2. You can see that becomes 6 plus a negative 6, which gives me a 0. Therefore, I must have 3 berylliums, 2 phosphorus, but let me rewrite that without the charges and in one single color. This is simply going to be Be3, P2. Notice I have used subscripts to explain to the reader how many of each atom I have. Let's go to my last example, lithium oxide. Again, lithium is simply Li. Oxide comes from oxygen, that's just O. I need to determine my charges. Lithium would have a 1 plus charge. Oxygen has a 2 negative charge. Let me do my quick math and see where I am. I have a positive 1 plus a negative 2. Again, that's going to give me a negative 1. That is not a neutral compound. This is a little bit easier fix than beryllium phosphide. I simply need to multiply my lithium by 2, and that changes that to a neutral compound. So I must have 2 lithium atoms. Let me rewrite that a little prettier and without my charges. Lithium oxide. When determining the molecular formula from the name, you need to be confident in looking at the periodic table and determining the charge on those monoatomic ions. If you have any questions about that, I encourage you to go back and look at electron configurations, octet rule, valence electrons. That is how I determine my charge on each of my atoms. Obviously, if we get the wrong charge on the atom, we are going to end up with the wrong molecular formula. So you want to be comfortable in determining those charges. Some of you may have learned the shortcut called crisscross when you are determining how many of each atom you have. And as long as you don't already have a neutral compound, crisscross works great. So I encourage you to rewind this video, take a look at our barium sulfide. That is a case where crisscross does not give you the correct compound. So it's great, it works in most cases, but just use caution when you use crisscross. Have fun naming, and thanks for watching.